We're going to talk a little bit about measuring in science, and we measure a lot in chemistry, and you guys measured a lot in the density lab. We haven't talked about that. But you did some measurement, and hopefully you did some very careful measurement, because that whole lab, getting at densities of unknown substances, was really intended to start you thinking about these concepts, accuracy versus precision. So, have you heard these terms contrasted before? Good. This is a favorite topic of debate in my house between my husband and I, as he will say, I don't think that was very accurate, and I will say, well, actually it was accurate. It wasn't really precise, and we like to bicker back and forth about accuracy versus precision because we're geeks. Accuracy is whether or not you're right. It's how close you are to correct. And precision is the ability to make the same measurement with the same tools in the same way and get an answer that's close to what you got the last time. The more precise an instrument is, typically the more expensive it is. Precision instruments tend to be pricey. So the triple beam balances that you guys use, and chemistry students every year go, can't we use electronic balances? No. We have some. There are a couple labs where I pull them out. For one thing, they don't go, you cannot measure as precisely with them. They only go to 1/10 of a gram. These go out to 1/1000 of a gram. The triple beams are precise. You're doing a good job, you and your lab group. You should be able to take the balance that was assigned to you and measure the same thing 3 times and get the same mass 3 times. Take it off the balance, walk away, go to the bathroom, get a drink, take that same object, put it back on the balance, measure it again, get the same answer, get the same measurement. They are not accurate. How do we know this? Well, if you take that same object and you measure it on every single balance in the room, you're going to get 6 different masses for it. And the reason that I assign a balance to every lab group now is because we didn't used to do that. And if you didn't write down the number on your balance and you measured your product after the lab, you would find that, hey, we had a 13% gain in mass. No, you didn't. You have the wrong balance, and the balances are precise. They're not accurate. So precision is really, it's about the instrument and it's about your skills. It's about being able to make that measurement with the same instrument, get the same measurement again and again and again. It's used again and again and again and again. If I do this, am I accurate or am I precise? Am I neither? Am I both? What do you think?
If you're trying to get
I'm trying to get bullseye, yeah.
Yeah, if you're trying to get in the center, you're both, because you have 2 that are around it and 1 that's in the middle.
Okay. So I have an argument for both accurate and precise. Anybody want to make a different argument? Okay, just accurate, not so precise.
If you were precise, you'd be getting it in the middle, so you need to get the same measurement.
Okay. I would argue that it's more accurate than precise. Now, it's not terrible. You know, you could have this, and that. If you take the average of those 3 shots, hey, it's bullseye. It doesn't matter because you didn't hit the middle. Those we would typically say, yeah, not accurate, not precise. If you can do this, accurate, precise, neither, both. Precise, yeah. You're able to replicate, you're able to hit the same spot repeatedly. You're able to make the measurement again and again and again, but you need to re-aim. And I had a student years ago, and I'm not a squirrel hunter, but he said, oh, this is like sighting in a .22. Okay. So if anybody has sighted in a .22, this is a good analogy. I cannot explain it any further than that because I'm not sighted in my .22. I just point it and the groundhog goes bonk. So, accuracy and precision. Great. Now what does this have to do with sig figs, which is what you promised you'd be torturing with us with next? I'll read it and then shut up and let you copy for a moment. Significant figures. This is the juice of the matter today. Sig figs in a measurement are all the digits known with certainty plus 1 additional digit. And when you measure on a scale marked in centimeters, you can measure 1.0, you can measure 1.5. You can't measure 1.25. Your eyeballs are not that good. You do not have caliper eyes. We talked about this a little bit when we were talking about the balances. And that, you can look at this and you can say, it's there. Yeah, I'd call that, on a scale like this, you can probably say, yeah, that's definitely not 1.5. I'm going to call it 1.7. That's probably not unreasonable. You can't say, that's 1.75. That's way more precise than you're able to be with that instrument. So you can only estimate one additional digit. You can never have two additional places in a measurement that you take. Where this really shows up, so let's say we've got this same scale. And let's replicate this scale 3 times. I do love docere for this reason. Okay, I got 3 different scales, drastically different. On this scale, if I tell you that this is a 4 centimeter long measuring device, and I hand it to you and I ask you to measure something, well, that's a terrible example. It's really awful. Yeah, okay, we'll make it work. You can say something's about half of that. You can say something's about maybe 0.8 of that. You can't say something is 2.75 centimeters long. You can go one place beyond that. If we have the one that we were using on the other side, you can probably estimate tenths. You can't go any further than that. If we look at something like this one, we blow this up. This is where when you get down to really fine increments, you really can't estimate anything more than a 5 or a 0. So if you end up here, you're not right on the number. The question you ask yourself on a very fine scale is, am I closer to 0 or am I closer to halfway? And you really can't say more than that. Does that make sense? Okay. It matters because there's a huge difference if I ask somebody to estimate the amount of paint needed for a room, and what I don't know is that the only tool they have is a 1 meter long stick with no markings on it. There's a difference in how good their measurements are versus somebody who has a ruler that's delineated in millimeters. So that's about the precision of your tool. Now, how does this play into sig figs? Sig figs are how we keep track of that. Anytime that you are handed a number, you are assuming that this is a set of measurements, and one of the pieces of information you're assuming is in that set of measurements is how precise the tool with which the measurements was made. That's the big deal right there. That's the big deal with sig figs. They are a way of keeping track of how precise a measurement was to begin with. Because if I handed somebody, if I hand somebody a set of measurements for a room, and like I said, what I don't know is that those measurements were obtained with an unpainted 1 meter long stick. They're not terribly precise. You may get really different numbers if you measure that again, because the instrument you're using doesn't lend itself to precision. You can't then assume that any calculations you do using those measurements are going to be any more precise than the first set of measurements was. So however precise the first measurements were that you were given, that you're starting off with, your givens, that limits how precise anything that you do with those numbers can ever be. So, sig figs are rule-based. This is in your book. These rules are in your book. They're in the notes. You're going to copy them, but what's really going to happen is you're going to use them and you're going to learn them and you're going to internalize them. I've internalized them to a point that I'm embarrassed to talk about, where, like, if I look at, like, the price of something, I do sig figs in my head. It's kind of weird. But remember that they're just a way of keeping track of how precise a set of measurements was. Anytime somebody hands you a given, hands you a number, if there is a number there that isn't a 0, that is automatically considered significant. Okay? If it's not 0, it's significant. That's pretty easy. Zeros, I couldn't put it any better than I did there. They're weird. Zeros have these rules, and for years I didn't understand why they had the rules. And so I think I couldn't internalize the rules because I needed to understand why. And so I'm hoping I can do a better job of explaining the rules and why the 0 rules exist as we go. But for today, we're probably going to have to mostly accept them. So if you have a 0 between two non-zeros, it's significant. It's like it borrows its significance from its neighbor. If you have a 0 that's out in front of a bunch of non-zeros and it's behind the decimal, actually, or if it's in front of the decimal, if it's in front of non-zeros, it's not significant. It's a placeholder. Okay? It is just holding the place. If it's at the end of a number and it's behind the decimal, which I guess is to the right of the decimal, it's significant. And at the end of a number, we can make it significant or not. Okay? So 300, that's not significant. There's no decimal sort of capping that. 300 with a decimal behind it, those two zeros are both significant. Okay? We're going to practice, and for the purposes of practice, we're going to name our rules. 1, 2, 3, and 4. Okay? So I'm going to give you numbers. You're going to write them down. You're going to tell me how many sig figs are in them. And then you're going to justify whether a 0, and you're going to say which rule you're relying on. Okay? So what I want you to do is write down how many sig figs are in each of these and figure out which rule you're basing your answer on. I just realized that I didn't record any of that, but hey, oh well. The difference in precision. So, telling how many are significant is easy. Rounding with sig figs is a little different. Did I do this one out of order also? Hold on. Let's actually do one other slide before we do that one. I apologize. So you have a given, either a measurement you took or a number you were given that has some number of sig figs, and what we have to do is keep track of how many sig figs you started with, because that tells you how precise those instruments were. So there are two different sets of rules. There's a set of rules for adding and subtracting. There's a set of rules for multiplying and dividing, just like scientific notation. When you're adding and subtracting, you're actually looking at decimal places. When you're multiplying and dividing, you're looking at overall digits, overall figures. So when you're adding and subtracting, because you're lining up decimal places to do addition and subtraction, you can't go any further behind the decimal than the least precise number you had. If you finished copying that first chunk, let's go do an example with that, okay? Okay, if I have two sets of measurements, I have 1.5 grams and I have 2.75 grams. These were apparently made on balances that had different scales. One was more precise than the other, or somebody didn't do a good job making sure that their measurements reflected the precision of their instrument. Well, I'm constrained, I'm limited by this number. So my raw answer for this is what? 4.25? 4.25 grams. But I can't have that decimal place in my answer. That's more precision than I'm allowed. So my raw answer is one thing, but my correctly recorded answer is going to be 4.3 grams. Okay. In each case, even though the rules are different for adding and subtracting and multiplying and dividing, it's always the lowest number of sig figs. It's either the lowest number of places behind the decimal or the lowest number of total figures, but you're always going on the lowest level of precision available to you. When you're multiplying and dividing, of course, you can take 1.5 times 1.5. What'd you get? We get a raw answer of 2.25, but we can't have that many places overall. Now, in multiplication and division, like I said, it's not down to decimal places. We're just tracking total numbers. So we can only have two. Our final sig-figged answer will be 2.3. If we take 3 times 0.5, what do we get? 1.5 is our raw answer. How many sig figs are we allowed? 1. Guess what our rounded answer for that is? 2. Okay. These rules you're just going to practice, you're going to use, you're going to internalize. Kind of like identifying how many. So, these are easy. What I'm going to show you next is the tricky part. It is rounding. It doesn't seem tricky. You all know how to round, right? Been rounding since, what grade did they teach you rounding in for the first time? Somewhere in middle school, probably? Okay. When you're rounding with sig figs, figure out how many you have first, how many sig figs you can have in your answer. Count sig figs starting from the very first number that you've got, and what I typically do is I underline the number I'm going to keep, and I literally, and this looks stupid, but hey, it keeps me from screwing up, I draw myself a little arrow to the next number, which tells me I am rounding this number based on this number, okay? I am rounding the number that I get to keep based on the number that comes after it. The rule we use is really easy. 0 to 4, rounds down, digit stays the same, you round down. 5 and up, you round up. Easy. That's easy, right? You know how to round. Okay, so we've got this big giant number we got from somewhere. If we look at all of our data coming in and we can have 10 sig figs, I'm going to write this number down, 607516.0611. Okay, 10 sig figs. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I guess that was already. Silly me. Okay, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm going to round that number, and I'm going to round it based on this number. That number's a 9, easy breezy, 0.675116.0611. Okay, and that's really easy up to there. As long as I'm rounding behind the decimal place, everybody understands this. People do not screw that up. I'll give you the example of the one place they do screw it up, but that's easy. Big number, some decimal values on the end, people do fine. If I have this big, beautiful number that I got, 607516.06109, and I look at how many sig figs I'm allowed, and I'm only allowed 4 sig figs. This is what people screw up. And I'm going to tell you that flat out and in front, this is what people screw up. So I'm going to start counting from the very first number that's significant, and that's the first one. So I go 1, 2, 3, 4. That's the last number I get to keep, and I'm rounding it based on that number. Okay. 6, 0, 7, 5 is what people want to do. Now, if I owe you $6 million, and I tell you, well, I'm going to give you $6,000, we're cool, right? You're probably going to take issue with that. Placeholders are really important because what you're going to replace these numbers that came before the decimal with, you have to maintain their places. If those disappear, everything shifts over. You got to put 2 zeros in there. Okay? And the rounding or staying the same is based on the number that comes after it. That is what people screw up. So, that's the first big mistake people make. Let me show you the second big mistake people make. Okay? Because we might as well just cut to the chase and show you the mistakes first, right? I have this number, 0.00517293. Okay, great. And I look at my number of sig figs that I'm allowed, and I can only have one sig fig. Here's the critical piece. Count sig figs beginning from the first significant number. So where's the first number in that that's significant? Which one is it? The 5. So I want to start counting from here. Oh, and I can only keep one. I'm done counting. Ah! And I'm going to round that based on that. I'm about to fall off my chair and give you all a comedy jewel. That would really hurt actually right now if I did that. That would not be good. So my final value for this is 0.005. If I looked at this and I was told I could keep 2 sig figs, so that's rounded to 1 sig fig. I go 1, 2, and I get 0.0052 because I'm now rounding that based on that. Okay? I'm going to give you 2 practice sheets all at once. It's a big chunk, but they're pretty fast and easy. I'm going to put the keys on Classroom. As you complete problems, you check them for yourself. My debate is between a FIP quiz tomorrow, though I will not be here, and a FIP quiz on Monday. We'll see. Practice is on Classroom. Keys are on Classroom. Go, do it, practice, learn it.